Hi everyone. So in this lecture we are going to see the implementation of circular queue using arrays. So I would write a program to implement the circular queue in C language. So while writing the program, I would also explain the steps involved in the development of circular queue program. By executing this program, you would be able to learn how the operations on circular queue can be performed and what are the details involved in the circular queue operations. Yeah, let us start writing the program. Um, so let me include stdio.h. I would also need stdlib.h. I am going to use exit function for exit function. For that reason, I am going to include stdlib.h also. And I need some global variables like the queue. I am taking the max size of the queue as 10. Front. So I would initialize front to -1 and rear to -1. The reason for this is I am setting the queue to the empty state. So if f is -1 and rear is -1, the queue is in empty state. So it is totally empty. Now let me start writing the main function. So in this main function, what I would do is I would display the menu, and based on the user's choice, a particular function like insertion into the queue, deletion from the queue, displaying the elements of the queue can happen. So I would be writing separate functions for insertion, deletion and display. So let me write the code for presentation of the menu in main. For this one, I may need certain variables like x, ch. Okay. Now let us display the menu. Printf \n1 insertion insert \n2 deletion. Some people call these insertion and deletion operations into the queue as NQ and DQ. So they are also same. So as I am writing the simplified, very most simplified version of circular queue, I am just avoiding all those jargons. For exit, and then I would ask the user enter your choice. Scanf %d %ch. If the user chooses the option 1, insertion is to be done. If he chooses option 2, deletion is to be done. If he chooses option 3, display, option 4, exit from the menu. These are the 4 operations we are allowing. Then, as we have multiple options to work with, switch is the suitable statement. I would take switch statement. Then case 1. If the user's choice is 1, what is to be done? Read an element from the user. So that is \n, enter the element to be inserted, scanf %d &ch. Sorry, not ch, this is x. Now let us call the function insertion into the queue, and what is to be inserted? X. I will pass this x as parameter to insertion function. The code for this insertion function is not yet written, we will write later. Break. Case 2. Break. Here nothing is to be printed, just we will call the operation deletion. Sometimes we can also extract the element that is deleted from the queue and we can display that element. So as I told you already, I am writing the most simplified version of the circular queue. I am avoiding all those extra fittings, for example. Deletion would be done. Break. Case 3. Display. As I have already declared the queue, front, rear as global variables, I need not pass them to these functions. As I have declared them as global variables, they will be available throughout the program. That means they will be available for all the functions. Break. Case 4. Case 4 is like exit here. Now let me write a default statement. Default statement will be activated when all other cases fail. Suppose if the user chooses some other option other than 1, 2, 3, 4, we can say it's wrong choice. Okay, this is the end of the switch statement. End of switch statement. And to provide the user with additional flexibility, like he can keep on work with different options of the menu continuously. To provide that feature, I am using one infinite loop while 1. While 1 will be always true and it will keep on executing the statements inside the loop forever. Then what is the remedy for this one? So if it keeps on working in infinite loop, then we should manually take care of exiting from the loop at one point in time. So if you choose case 4, that will bring out the control from the loop. So that is why I am, without any hesitation, I am using this infinite loop while 1. Then, so this is about the presentation of the menus and various options. Now let me write the actual code. that is the functions. So void, first I will write insertion function. If you observe the signature of this insertion function, it is like void insertion int x. Void means the function returns nothing. The name of the function is insertion, and it is taking one parameter, that is x, which is of type integer. As I told you already, the q, front, rear are declared as global variables. They will be accessible to main as well as the functions. When we insert, the first thing we would check is whether the queue is full or not. Why? Because we need at least one empty location to insert the element into the queue. So if the queue is full, we cannot do so. So that's why we will check whether the queue is full or not as the first step. In circular queue, the conditions to check whether the queue is full or not is in two ways. One will be rear reaches max size minus 1. Max size in the sense n, that could be n. Here I am taking max size as 10. If rear reaches 9, we cannot accommodate one more element. Okay, so that is the condition for ordinary queue. In circular queue, rear reaches max size minus 1 and front is still at 0. Then that indicates the queue is full. Another case which indicates the queue is full is if rear is exactly front minus 1. Then also we can say the queue is full. Let us incorporate those two conditions in this if statement. The first condition is rear equal to max size minus 1. In this case, max size minus 1 is 9. As I am taking 10 as the max size here, and front is still at 0. This is one condition that indicates the queue is full. Another condition is R rear equal to front minus 1. Am I putting all the parentheses opening, are all the opening and closing parentheses matching? Yes. This is one parenthesis pair, this is one parenthesis pair, one for this one for this one for this whole condition, and this one for main if statement. Okay, fine. Printf queue full. Else, what is to be done? Rear is to be incremented by 1, and in that position we have to accommodate the new element. In circular queue, rear is to be incremented by 1 means sometimes it may reach max size minus 1 and there may be some empty locations available in the front of the queue where we can utilize those empty locations also. So for that reason, to allow rear to jump to some 0th position, 1, 2, etc., we will be using R is R plus 1 modulo division, max size, that is 10 here. So if rear reaches 9, it will jump on to 0th position if it is available. So that provision we are making here. Q of R equal to X. Fine. Then if front is still at minus 1, Suppose if the Q is empty and we are accommodating the new element, then front should be set to 0. If front is still at -1, front should be set to 0. Yeah. I think we have taken care of all the possibilities and conditions. Yeah, fine. Let us go for writing another function, deletion. As we have checked whether the queue is full or not in insertion, we have to check whether the queue is empty or not in deletion. That is the first thing we have to do. Queue empty. What condition checks whether the queue is empty or not? Simple here. If front is -1, we can say the queue empty. Else, if there is only one element available, in the queue, then the front pointer is to be set to -1. If How to check whether there is only one element in the queue? If front equal to rare, that means there is only one element. In this case, front is to be set to -1. That means the element is deleted, the queue is empty. R is to be set to -1. Else, if there are more than one elements available, then what is to be done? We can simply write F is F plus 1% 10, like we have written for rare. What will happen here is front will be incremented by 1, obviously. If front reaches max size -1, if front is there at max size -1, there may be some more elements available at 0th position also. So this front will be set to that 0th position. Here people write two conditions here. If front is less than max size -1, they will set front to front plus 1, otherwise they will set front to 0. So I am combining those two statements into one, and this will also work. I think I have covered this deletion operation. Okay, fine. Now let us go for writing display. In display function, we will normally display the elements from front to rear in linear queue. Here we have to take care of the additional cases also. Sometimes if you cover front to rear, there would be a break at max size -1 and 0. So there would be certain front locations occupied after rear also. So to cover that one, to take care of that one, we have to write these statements in two folds. So let us see what is that. Int I. If front less than or equal to rear, that means it behaves like ordinary linear queue. In this case, without any hesitation, we can write I equal to front, I less than or equal to rear, I plus plus. Printf %3d Q of I. This is like normal linear Q. If front is not less than or equal to R, that means if front is greater than R, in that case we have to write in a different way. Else for I equal to here how to write this one. Let us assume the scenario rare is at position 9, front is at position 0. So that we have covered. Suppose rare is at position 2, front is at position 4. Sorry, front is at position 3. How to write this one? So first we have to write 0 to rare, then front to max size. Okay. For I equal to 0, I less than or equal to R, shall I write like this or something like front to, first let me write this one, front to 9, max size minus 1, I plus plus, printf %3d Q of I. For I have covered from front to max size minus 1. Now what is left over here? I equal to 0 to rare. Yeah, I think we have covered all the cases of this display function. Okay, fine. Now let us run this one. So no errors here. Let us work with different cases of this, different instances of this circular queue. So initially, let me check this insertion operation. Enter the element to be inserted, 10. Let me display the contents of the queue, that is 10, that is fine. Insertion, 20. Let me display 10, 20, fine. Let me perform this deletion operation to deletion. Now let me display the contents of the queue. 10 is deleted, fine. Let me insert some more elements. One insert, that 30, let us insert 30. 1, 40, 1, 50, 1, 60, 1, 70, 1, 80, the plan here is like I will insert until the rare reaches max size minus 1 and then try to access the available front locations. So that is the real essence of the circular queue. So I am trying to demonstrate that. Let me insert some more elements. $90. Enter your choice 100. Let me check what are the present contents of this queue. 20, 30, 40, 50, 60, 70, 80, 90, 100. Okay, fine. So 9 elements are there. There is one front location available. We have deleted the 10 already. That location is available. Now front is at position 1. Rear is at position 9. If it is ordinary queue, as soon after the rear reaches max size -1, the queue is full. So here we cannot say queue is full. Why? Because there is one location available in front of this 20. Now let me try to insert one more element. It will not state queue as full. Let me take that element as 11. It will be accommodated. Now let me display the contents of the queue. You see 20, 30, 40, 50, 60, 70, 80, 90, 100 and then 11. So now the queue is totally utilized. Okay, so this is the circular queue, and if I choose the operation 4, it will exit from the code. So this is the circular queue program. You can pause the screen and you can also try implementing this circular queue. So most of the people, most of the students, they get confused with circular queue. They feel linear queue quite comfortable and they get confused at circular queue. There is nothing to get confused. So if you just work with pencil and paper and take few instances of the circular queue, you will be able to understand this very easily. Through this program also you can experiment with various options. You can work with various test cases and you can try to understand the nature of the circular queue.